Started. This talk is about really improving the performance of your data-aware applications. And I'm going to be talking about a couple of types of optimizations. Optimizations that you can make with SQL Server itself, and also optimizations that you can make with Visual C++. Kind of what we found is that you need to look at both pieces of the puzzle in order to make a very highly performant application. Now, in the talk today, I'm going to be doing several kinds of examples of things that you can do to improve performance in your applications. I'm going to be giving a few primers as we go along, so if you're relatively new to the field of optimization, hopefully this will give you a good jump start in improving your application speed. If you're a guru in this field, I also hope to have a couple of things in there that maybe you've seen before but never quite taken the time to look into. So maybe you might pick up something out of that as well. Throughout the talk, I'll be doing a couple of demos, and I'll be making those available for you so you can take those home and play around with those further. A little bit about myself. My name is Lon Fisher, and I'm a developer in the Visual C++ team. And I've been working at Microsoft for a little over 9 years now. That's about 63 years, dog years to you and me. Yeah. And during that time, I've had a chance to work on the original versions of MFC, from MFC 1 through 4.2. Worked on the first 3 versions of ATL. And now for the past several years, I've been working on the database support for Visual C++. So doing things taking over all the MFC database support, as well as introducing new support through things like the OLADB consumer templates. Now, one of the really good things about this talk is that all the optimizations I'm going to be giving to you today have actually been battle tested. So, I'm not going to be sitting up here and saying, in theory, I think that might work. All of this stuff we've actually run through in a very high performance situation, and we know that this stuff works. So hopefully these will be good pearls of wisdom for you to take home. Now, they inserted this slide on me here like yesterday. So I'm sitting here kind of looking at this, trying to figure out what to say about this. And really, I guess the way I interpret this slide is, doing WinDNA is a really good thing, but anything that you can do to improve the performance of your application makes it just that much better. It makes your life easier. At Christmas time, you're the one web server that stays up while all your competitors are, getting the old error 404, cannot connection timeout, So anything that you can do, either from the Visual Studio stage or from the SQL Server stage, will really help you out. If there are 3 things that I'd like you to take home today, it's first of all, Visual C++ and SQL Server give you the chance to get the absolute best performance. The reason for this is simple. It's all flexibility. With Visual C++, you can always go down one more level, tweak one more thing to get the best performance. We'll go through a couple slides a bit later, and I'll show you kind of what that all means, being able to just take one more step to get better performance. Second of all, when you're thinking about a highly performant system, you need to think about all the components in your system. It isn't enough just to have, the most optimized SQL Server stored procedure that you can imagine. It isn't enough to have the absolute best data access. You need all of those together to make the whole piece or the whole puzzle work. Your application is only as strong as its weakest link, so you need to think about that from start to end. As we go through the talk today, I'll be going through both sides of the equation there. Finally, little things mean a lot. I'm always amazed at how tweaking some small thing takes 5 minutes and it doubles your results. In fact, one of the things I'll be showing you later today is an optimization that we made during a recent test run, the PC Week benchmark, that literally doubled our results just by changing a string. So I'll be showing you how to do that as well. Again, as I said before, a couple demos in here, and then I'm also going to talk a little bit about some of the new SQL Server 2000 optimizations that have caught my eye, so things that you can do to go on even further, taking advantage of the new features in SQL 2000 to improve your performance even more. Okay. How many of you during the Christmas holiday season went up to a website and it was mighty slow, or you couldn't even get on? You know, I had that happen a couple times. You know, get the old error 404, connection timeouts, you know, or something, some other such nasty error from your web server. And you know, I mean, the press seems to really jump on all these companies whose web servers go down anymore. I mean, you know, you just something goes down, and 15 minutes later, you know, it's on CNBC, or you know, pick your favorite news channel, and oh, so and so's site's down. Well, all of this really, to me, comes back to performance, both in terms of how much you can, how many pages you can serve, but also how many users you can handle simultaneously. Well, the folks at PC Week felt last summer that it would be interesting to do kind of a test between a number of different vendors' application servers to see just how well or how performant their web apps could actually be. Kind of the rationale from this is that if your website didn't have a good amount of performance, then you know, you were in a fair amount of trouble. Now, for this test, PC Week invited several competitors, you know, ranging from Sun, Netscape, Apple, Bluestone, several others. And you know, by no means, you know, all these competitors were, are extremely good companies and really have, really gave us good challenge. About May last year, they ran into my office and said, "Lon, guess what? You've been elected to do this." And I said, "Okay, what does this mean?" "Well, we want you to win." "What happens if I come in second?" "Don't come in second." Yeah. So we had that kind of challenge, that had to go, and I think also we as developers, when we get that kind of challenge put in front of us, we always kind of enjoy that the most. So we kind of adopted that healthy paranoia and said, okay, what we're going to do is use Visual C++ and all of its flexibility to create a lean, mean app that'll do really well on this benchmark. That being said, we didn't really know how well we were going to do until we actually ran it. Now, the benchmark itself, let me talk a little bit about that. It's called @bench, and it's really designed to measure three separate things. First of all is performance, and in performance, they measure that in two ways. First of all, if you have a web server, how many peak pages per second can it serve at a particular user load? So what they would do is they'd keep increasing the number of users on your system until they figured out the absolute highest number of pages you were serving at any given time. That was just kind of the raw output. The second test that they applied was to keep increasing the number of users until the average response time for your page went over 3 seconds. Now this was an arbitrary time that was chosen to represent the point at which a customer gets frustrated, hits stop, and goes to a competitor's website. So as soon as that happened, they took that measurement and stopped. The second thing they wanted to measure is scalability. Now, we'd all like to actually believe that, if we add another server on, we should, in theory, get double the performance, right? Unfortunately, that isn't necessarily the case. I've seen a lot of cases where people actually get negative scalability by adding on more hardware because they're now contending more for existing resources. For example, you have several web servers now going on one database server. So you want to measure what's going to happen when you add on an additional piece of hardware, and you want that number to try to be as close to 1. In other words, it doubles your performance as is feasible. Last but not least, fault tolerance. Hey, bad things happen, right? Motherboards go, disk drives let loose. In Seattle, we have a particularly bad power system that keeps flickering on and off. Any sorts of thing can happen. So what happens if one of your web servers just goes down? To measure this, what they did was to actually go up to your web server while the app was running, at some random point, just pull the net plug. What they wanted to measure was, first of all, what happened to your website, and second of all, for any existing transactions currently on that web server, were they saved or were they lost? In other words, if you're buying a book and the web server goes down, that should be totally transparent to you. You should still be able to just go to a different server and still complete your purchase. So as the end user, you should never know anything is wrong with that system. Now the big caveat here, all shipping software. So we used NT4, SQL Server 7 for our system software. Now this particular benchmark is meant to represent an online bookstore. Geez, where have we heard that before? And particularly what this is supposed to do is to emulate the different things you might do in a bookstore. So you can browse by subject, you can search by an author or title, you can add new users, you can purchase books, so on and so forth. Now the database here is probably, for some of you, you're looking at this pretty tiny. For some of you, you're probably looking at, hey, that's pretty large. Yeah, we'll call it in the middle, moderate. 12.5 million row database. I think the reason they kind of kept it about that size was just to keep it kind of transportable from one system to the next. Those of you guys have terabytes of data. You know what I mean, how much fun it is to move that around. Now, here's the results. Now, if you can't read this, the top line is Visual C++. Okay? The middle line there, that middle dashed line, is an implementation we did from Visual Basic, using all the Visual Basic components using ASP. The other lines below that are some of the competitors. Now, if you're a little bit surprised by the results, we were definitely surprised by the results. I was figuring the whole time, maybe we'll eke out maybe a 10%, over these guys, and we'll call that good. But in some cases, in terms of peak pages per second, how many pages could we shove out through the door, we actually beat some of them by 400%. Now, there's a little known fact in there. We were allowed to use either 4 or 8 servers. It turned out that our application was running so well that we bottlenecked a 100 megabit network that it was running on. So we actually achieved those numbers with really only 2 servers out of the 4, because we pretty much had saturated the network at that point. So, indeed, we were really surprised by a lot of these results. Kind of a second page is the number of users that 3-second measurement I told you before. How many users before you passed over 3 seconds? And again, we did very, very well here, in I guess almost doubling the nearest other competitors. So, we kind of looked at this. We'd been kind of heads down for several weeks, kind of throwing all this stuff together, really trying to do a good job of putting this web server together. We come out, we see all these results, and we go, wow, this is pretty surprising. So then we start thinking, well, what did we do that was so good? How did we do that? Well, we started to look back through all the different optimizations, what they meant for us, and guess what? Now I'm going to tell you about it. So you can take all this home. One quote I have to put in here, this is my favorite quote, so humor me a little bit. I just love the concept of the app going through like a bolt of lightning. I have that kind of hang up on my wall. That's just kind of one of my favorite quotes from that whole thing. But it kind of again points out we bottlenecked this 100 megabit network. And really there, it was just a matter of using good optimizations, both on SQL Server and on Visual C++. I'd estimate 50% of our results were due just to good database usage. In fact, from what I kind of heard from some of the quotes they put in about some of the other competitors, I kind of had a sense that some of their databases, they had a harder time tuning than SQL Server 7. One of the things you'll always get me to say is how great SQL Server 7 is in tuning, because it gives you feedback. It tells you if what you're doing is right or not. But another other thing that we did is we took just full advantage of both C++ and all the things that you could do. Our web implementation was just a standard ISAPI extension. Simple little DLL, coded in C++, very small. I think the final implementation was 35K, just sitting out there running on these web servers, running away. The other thing that we did is, boy, we tuned like crazy on SQL Server. And from that, we came up with a good set of things good set of pearls of wisdom, if you will, that you can take home and use on your apps. Now, there's, a lot of times I'll be looking out on news groups, and I'll always see someone kind of making a statement like, well, this is faster than this. And then you start taking a look at their code, and you realize that all they've done is the bare minimum of work. They haven't really started to spend time to investigate why are things fast. Why is database, why is all this important? Why when you go back to your boss and he's going, well, why are you spending 3 more weeks on this stuff? The thing to tell him is that this can make or break your performance. I absolutely believe that our numbers would not look nearly as good if we not had gone through and done all the optimizations. The other thing is, if you're doing different data access methodologies, all of them have their own gotchas. There's things to watch out for with ODBC. There's things to watch out for with OLADB. There's things to watch out for with ADO, and so on and so forth. You've got to understand those to do a good job. Now, one of the things that we found that really surprised us is one of the things that we found that what you never want to do is avoid making SQL Server compile your code. In other words, giving you a SQL compilation. And we kind of ran across this kind of by accident. And then once we figured out what it was kind of one of those light bulbs that go off in your head. But it's really important whenever you're looking at database optimizations, keep that perfmon running and take a look at your SQL compilations. We actually got a demo of this in a little while here. And watch out when those things go above 1. If it goes above 1, you probably got a little bit more tuning to do. Now, before I get into this too much further, I want to talk about the methodologies that we used and why. I know for a lot of people this can be a really religious subject, and so kind of what I'm going to talk about is kind of the best points of each. We particularly chose ODBC for our layer, mainly because we're going against SQL Server. We're going against one database, and it's very small and fast in that environment. And also, it arguably has the best bulk fetching semantics, which is one thing that we took advantage of with SQL Server to improve our speed. One of the problems, remember, we had a big problem with the network, so anytime we could minimize a network hit, we would take advantage of it. There's a question all the way back there.
Is that a function of the SQL Server ODBC driver, or is that general ODBC versus OLADB issue?
And that would be actually kind of both. The question was, is that just a general ODBC driver statement or a SQL Server statement? It's general in terms of ODBC in that ODBC gives you better bulk fetching semantics, but also it's SQL Server specific in the way that the SQL Server cursors start handling rows that you want to fetch. Specifically, one of the cursors, I'll talk about this in a little while, actually starts downloading all of your data even though you've only fetched maybe only 1 row. So you've got 50 rows, it starts sending all of them down the pipeline even though you've only done 1. Using both of those together, it really helps. Now, we've been talking about OLADB for a couple of years, and people might say, wait a minute, why'd you use ODBC instead of OLADB? Isn't that backwards? Well, OLADB would have worked really well for us too, again because we've been using the native SQL Server provider. However, in my opinion, OLADB has kind of a little bit different bulk fetching semantics, and I don't think they're quite as good as ODBC. In other words, in OLADB, what you do, instead of fetching 10 rows of data outright, you fetch 10 handles to rows, and then you fetch the data for each one of those rows. Now, your provider is probably smart enough to say, we asked for 10 rows, maybe I should page all those into memory. But if your provider doesn't do that, you're still going to have some performance implications there. So that was, kind of the very narrow, 1/10 of 1% margin that kind of swayed it for us. Now, the Visual Basic application used ADO, and for some of you may be looking at ADO as a good data access methodology. It's easy to learn, pretty quick to get started with. We looked at that, and we noticed one difference. We noticed that on the web server, the CPU utilization ran a little bit hotter than it did with either the ODBC and OLADB methodologies. We think the reason for that is that ADO tries to do much more on your behalf to make your experience easier. So in other words, what it's doing is it's asking the provider for more information than you would otherwise have to. So kind of the result of that, it's making the web servers themselves run a little bit hotter. Now remember, with ADO, OLADB, and ODBC, pretty much at some point, all of this is local to your process. So we're talking somewhat about apples and apples there. In the terms of ODBC, it's your driver manager and your driver. In OLADB and ADO, it's your provider. So again, if you might be thinking about, well, is something out of process and I've got to worry about that? Usually in these cases, it's usually in proc. Now, I mentioned a couple seconds ago, the question right here.
Did you test that with ADO 2.5 as well, or do you know if that made any difference?
I should say we tested all of this because we had to use the shipping software. We couldn't use the MDAC stack off of Windows 2000. So the one that we used would be an MDAC 2.1 SP2. Would have been the stack. So ADO 2.1 SP2, OLADB 2.1 SP2, and then ODBC 3.5.
I was just wondering if the numbers still are the same in Windows 2000.
But believe it or not, we're actually rerunning some of those numbers right now. Unfortunately, I don't quite have them to put down on the sheet. So I really couldn't say as to the difference between those. I would expect them, though, to be a bit better because they have continued to do more performance optimizations within ADO, though. So that's something to keep in mind from version to version.
What are the contention issues with ADO 2.1?
The question there was, are there thread contention issues with ADO 2.1? Not that we really saw. At least we didn't run into particular problems with that. Now, there are some things that you can really run into trouble with. For example, the shared property manager from like MTS, things like that, that's kind of, sort of, data. But we didn't really run into any problems from just our usage of that. Okay. Let me get on to SQL compilation. How many times have you ever been looking at a problem and you're looking at it and you're looking at it and you haven't got a clue, and all of a sudden the light bulb just clicks on and you realize what's wrong, and 10 minutes later everything's great? That's kind of the situation we had with this. To kind of give you a little story, we're about 2 days from the end of this project, and we've shipped out all the machines down to this test lab in San Francisco where the official tests are being running. And we noticed that our database utilization is a lot higher than it should be. I mean, we're running like really close to 100% in our database utilization, and we can't squeeze anything more out of the database. And we're going, geez, we're hitting this at relatively low user levels. What's the deal? Well, one of the guys, running Perfmon comes up and says, well, there's these things called SQL compilations going on. What are those? And of course, at the time, we look at it and go, I don't know. I called up Luber Kolar, one of the other speakers here, and I asked him, I said, what's a SQL compilation? And if I'm getting more than one, is that bad? And he all of a sudden goes, oh, that's it, it's really bad, don't do that. What's causing this? What's the problem? So we started looking at what it was, and it suddenly struck me that what SQL Server really is a compiler. We often think of SQL Server as a database, but what happens when you pass in a query, right? It's got to go through, and it's got to effectively parse this, validate it against all of its tables, make sure the data types are right, make sure that ranges are right, everything. In effect, it's a compiler. It's doing the exact same thing that our standard VC compiler would do. Now, normally, SQL Server only compiles something when it first sees a new textual statement. So the first time you call a stored procedure, first time you make a specific query, it'll go through and pretty much check it all against its internal metadata, and then it will put it in its cache. And that's usually a good thing, but when it's compiling itself, it really does slow down your database because it is using more resources, and you will see that little disk light churning, which is usually not a good thing when you've got 10,000 users currently pounding on your servers. Now, hopefully, after this is compiled the first time, it stays inside of its cache memory, which you can actually configure with SQL Server. You can raise that up or down. I usually like to keep it plenty large, depending on how many stored procedures, how many different things I'm going to be accessing. Now, if it's in the cache, the next time you come along, you call that stored procedure. It's like using a pre-compiled header from C++. It's already there. It just gets dumped in your code and away you go. So it's a lot faster. However, there are some things that you can do, some things that may not even look like it, that will cause a problem that can force a recompilation. Now, Couple things that got us. We found that in general, never call by value or never call by prepare. If you look at the top SQL exec direct here, it says call spfoo, comma, or quote myval. What we're doing there is we're calling a stored procedure with its parameter by value. In other words, we're textually dumping the value into the string. Now, at first glance, you say, well, it's the same stored procedure. You know, what's going on here? What's the difference? Well, it turns out that string is different. So when SQL Server sees this, it's going to go, this may be different than the last thing I looked at. Maybe I better revalidate this. Bang, there's a compile. Turns out, by changing that string ever so slightly to bind by parameter, which I'll show you on the next slide, get all that to go away, because it'll be the same string. Now, the second one surprised me a lot. It's SQL Prepare. SQL Prepare has kind of two negative effects. And in our case, it turned out that really we wanted to get rid of this code as fast as we could. First of all, it forces an extra network hit. It forces the ODBC driver, the OLADB provider, whatever methodology you're using, to go out to SQL Server and say, now force a compile on this guy. Get it ready. Now, SQL Prepare can be very useful in ODBC for doing things like you're trying to call a stored procedure and you don't know how many parameters it has. It can be a useful thing. But in our case, because we always knew at compile time how many parameters we had, what their data types were, what their possible values were, it was a big waste of time. So in essence, we're going and asking the database to do work that it's going to do anyway. It's already going to do as part of the SQL, just calling the SQL statement. So in a sense, we're just making the database work that much harder. So, calling by value, calling by prepare. The funny thing is, you look at this code, and this code looks totally reasonable when you're looking at it. But in reality, it's just can be causing you a fair amount of trouble. Now, in my opinion, the right way to call this is to bind by parameters. And what I've done here is I've given an ODBC representation of this. And what you do in ODBC is you would call SQL bind parameter. In OLADB and ADO, you would use a different semantic, but effectively, all the methodologies have a concept of binding a parameter. And effectively, when you do this, what are you doing? Well, you're telling it the ordinal of the parameter, the data type, how big the data is, a number of things. All of that goes off to SQL Server, so it now knows every time you put a value into that parameter, it's going to be within a known range, known value. So therefore, it doesn't have to recompile. So if you bind an integer, for example, it knows what the possible values are. It knows how big it is. So it doesn't have to waste time doing that. Now, in our case, if you look down at the bottom, on the bottom line of code there, the SQL exec direct statement, notice we change this ever so slightly to be a question mark. The question mark is kind of the ODBC call syntax to represent a parameter. The nice thing is, every time you call this, the string remains the same. The only difference is the value, in this case, in the data member SZ param. That's the only difference. So when SQL Server sees this, if it's been called before, should be in your cache, should be ready to run. So it's Thursday night at about 11:30 p.m. The guys are pulling their hair out trying to figure out how to do this. I figured this out. I call them up, tell them what's going on, tell them what to change their code. About 1 a.m., they call me back, and they say, our database just went from like 85+% down to 40%. Our SQL compilations were going like 230, went down to 0, right? Our performance just doubled. One thing, changing one string, doubled the performance. Now, granted, we're doing this in a pretty extreme case, but it's a good example of how those things, don't make SQL Server do extra work. It's a question over here.
Is connection pooling automatic in this approach?
You're asking about connection pooling?
Yeah.
Okay. In this case, was connection pooling automatic? In our case, believe it or not, we actually turned connection pooling off. Might sound kind of surprising, but the way we designed our app is we pre-allocated everything. We never wanted to be allocating as we went along, because you never know what the current state of your resources is going to be. When you pre-allocate them, you have a pretty good chance everything's going to be there. What we did was we actually allocated, I believe on each web server, we allocated 96 ODBC connections, or HDBCs, one for each of a worker thread that we were using. Now, the number 96, it turns out, is a bit arbitrary. We didn't really never had time to go back and experiment with all the different thread numbers. Some people will say it should have been 16 threads, 4 per processor. But in our case, we turned it off mainly because we were never going to release a connection until we shut the application down. So we didn't need any extra, we didn't need all the pooling code enabled. We didn't need it running. So in our case, we just turned that off. So, from that respect, that may be something to consider. You can actually turn these off if you don't need them. Now, with connection pooling on, what would have happened is our startup would have been a little bit slower as the pool would have grown up to 96, but it pretty much would have stayed there because we would never have released a connection until we shut the app down. Okay, let me get the question here and then the question. I'll do this one up front first.
So was your ISAPI DLL didn't have a thread pool that did create itself?
Yeah, so our ISAPI DLL, the way we did this is we had a thread pool consisting of 96 worker threads. And each thread on its stack contained a current database connection. That also turned out to be a smart thing because we didn't have to worry about thread contention or just contention for things among handles between SQL servers. So for example, like you've got an H statement, you're trying to use that in a multi-threaded application, you'll sometimes get an error back saying it's busy, try again later. By putting all this into one thread, or each thread stack, I should say, we avoided that because each thread was doing its own operation and had all of the things that it needed right there. There's a question back there.
Yeah, I'm going back to what you said from the past. Say if it's not necessarily connection pool, say if you're just talking about different connections, would the benefit of having your text be the same, not having to recompile that text, that would still occur if you're really worried about something?
Yeah. So the question is, even if without, regardless of which version of connection pooling what we had, whether we had it turned on or turned off, would we still have received the value of binding, in this case, by the parameter? Absolutely. The two are actually are separate. At least in my mind, they're separate from the standpoint that SQL Server is doing one thing, and then the other case is more how you're going to get to SQL Server over the connection. So in that case, the SQL Server itself knows it doesn't have to recompile a statement because it already has it handy, regardless of which connection it's running on.
So, sorry, just to clarify one point. When you pass, even though your string contains literally the same literal value, the y value, every time it's still recompiled?
In the case where it contains the exact same string, so like if I pass my val in 1,000 times, it wouldn't recompile because that string is the same. But now if my val was, say, my val 2, or some other different value, then it would be. Because the thing there is that it looks at the total string, and that's what it's basing on. Now, one thing I found is kind of experimenting with this, numbers themselves won't cause it to recompile. The thing you got to watch out for are strings, primarily. So for example, on this slide back here, where I did a SQL exec direct call spfoo quote my val. If that would have been just like a 1, and then next time would have been a 2 or a 3, chances are SQL Server wouldn't have had to recompile it. It's pretty smart on numbers. But in terms of strings, when you change like my val to my new val, it's a different string, and that sometimes can cause it to recompile. Okay, let me just show you how this. What I've done is I've kind of cooked up a demo here, and you can kind of take this home and play with it. And what we've got is an ODBC app, and I've tried to make this a little bit easier. The two apps are called Right and Wrong. It's the exact same stored procedure call, but one's going to be bound by the value and the other one's going to be bound by the parameter. Now what we're going to do is we're going to build these and run them, and we're going to be running perfmon, and hopefully, I was playing with this before, we'll see this big spike in SQL compilations with one, and then with the other, when we bind it by parameter, we'll just see it jump up to 1, back down to 0, and stay there. So let me switch over to my demo machine. Okay. Squirrel away a few things here. Okay. So what I have up here is an app called Wrong. And let me just kind of show you what's going on. It's an ODBC app. And the first several lines that we play around with is pretty much just hooking up to the database, allocating all the handles, and hooking up to a local database here where the DSN is called Nile. Now, if that succeeds, then what we're going to do is we're going to spin through and we're going to call a stored procedure 10,000 times. Now, the important 2 lines of code here, we're making 2 characters and we're kind of modding them with values to effectively make them look different each time we call it. It turns out this is the hardest part of the demo, to get different enough values to make this kick in. Trust me, though, you run this on a real-world app, it happens real quick, though. At that point, we make a call to our for a stored procedure, and notice, we've got the quote here and then the 2 characters together. We'll call that, and then we'll go through and effectively, free the handle, redo that again. Now, I should have this all built, and I've got perfmon running here, and I've got SQL compilations and selected for this particular server. Now, what in theory should be happening is we should see a spike up on the compilations. This represents the fact that it's having to put it into its cache. You'll then see it come back down to 0 because I've only got 2 characters and the thing I'm modding against is 26. So you'll see it after a while, the cache is full of all those. It's reusing strings, so it'll pop back down to 0. Let's give this a go. Okay, you see that line here coming up. That's our SQL compilations, and it's maxing it like, quite a bit here, about 800, and then it just jumps right back down to 0. Again, the reason is that it's the cache is now pretty much contained all the hits it's going to get. If I put a little bit more thought into that string that I'm passing in, I could probably make that line go on for a little bit more. Thing is, when that line is going up, SQL Server's doing work it probably doesn't need to. And what you'll notice is for those stored procedure calls, your return time from those is going to dip down significantly. Now, the first thing I've got to do here, I'm going to shut down SQL Server. And the reason I'm doing this is to flush the cache. It's primarily the reason. And once that's shut down, or while that's shutting down, I'm going to open up another project called Write. Okay, whoops. Get the right one here. There you go. Okay, now this one has the exact same code that we had before, in that it's going through and doing all the Nile hookup and everything, and it runs back through and it does 10,000 calls. But now this time it binds a handle for the character, or excuse me, it binds a parameter to contain the characters. And when we're doing that, we just create a value here called szparam, and then these 3 lines, we just dump the characters into that text buffer. At this point, we call the test search by author forward. By the way, this was the stored procedure we actually used in the run. And notice now that we have the paren, question mark, paren. So every time we call it, it's always going to be the same guy. Let me get my SQL Server started up here again, and let me just build this, make sure it's all built. Okay. And now, presuming that this is all running, my performance counter is pretty much cleared Here, let's go ahead and start this guy. Now you notice here, you can't really see it. There's a little beep right in the middle, right? It went up to 1 and went right back down to 0. Exact same call, just that it only compiles once. So there, it's, if I can't make a better statement on little things mean a lot, changing that string it just totally doubled our performance. And I think for a lot of people, take a look at how you're calling stored procedures in your queries, and it's a really good thing. It can really help your performance. Okay, let me switch back to my slides. There's a question back there.
In both the sample that you just showed and in some of the slides, you use some C runtime calls for string manipulation. Most of the docs we've seen in the field for doing stuff on the server says don't use C runtime.
Uh-huh. Very good question. The question basically is we're using some calls like strcpy and sprintf and things like that. And would they potentially have thread contention problems out in the real world? In that demo I used it. It turns out that we never used anything like sprintf, which tends to be a pretty nasty function for performance for a couple reasons. First of all, it brings in about 25K of C runtime startup code, which makes our little 35K application jump up to 60K, right? And then the other bad thing that it does or would do is that it potentially has more problems with trying to format with a lot of different threads pounding on it. So in the case there, I'm using it primarily for that demo because I'm running on a single thread within a single process. So that's a very good catch. In our case, what we did in the real app was to pretty much just do strcpy in, because strcpy effectively is, in the case where we're using it, almost just a memory transfer. It's a dump this into this, and that's pretty much all we had to do. So we did use the C runtimes, but we were very selective of the C runtime functions we use.
One other question on the same thread. The shell API exposes a set of non-C runtime string copy nodes. Is there a performance with those to make it different to use those or the other? Is there any notes on that?
Yeah, we didn't really go into checking whether the standard Windows functions like lstrcpy and things like that were any different from strcpy. Unfortunately, as always the case with optimizations, you never have enough time to check out every variable. So my guess is you'd probably see some difference. You would definitely see a difference in terms of code size, and that the shell API ones would be smaller, primarily from the fact that they're located in DLLs. You're not statically linking these in, as opposed to some of the C runtime code. Okay. There's a question right here.
For your demo for multiple threads, do you have to use critical sections and exception handling?
Good question. Did we have to use critical sections and exception handling? Okay. It turns out that we actually yanked all of our critical section code that we initially put in critical sections to, for example, help with the worker thread pool and everything. We ended up ripping it out. The reason is that we could never be smart enough, that we were never as smart as we wanted to be in terms of how to make that critical section code work great. What we ended up doing is whenever we had things like, in the pool was primarily the case we had to use it, we switched over and used I/O completion ports. And if you're interested in that, just look in MSDN for post I/O completion status, I think is the name. One API will take you to the rest. The thing is, these I/O completion ports, I have never seen something better at handling thread contention. They just hum. We didn't have to mess with it at all. So we went from a case where during testing, we're using critical sections, and we found one case where all of our threads slammed into this critical section, and then it kind of became like a stoplight, or excuse me, a stop sign. Only one could go through at a time. So we noticed our application's performance going great, bam! And it'd be sitting down here for a while. Then it would start to work its way back up, and bam! And what was happening, every time we triggered that critical section in force, our app just went crunch. When we switched over to IO completion ports, that line was nice and smooth because the system itself was taking care of all the thread contention.
So you were using the IO completion port purely as a synchronization mechanism?
Exactly. We're using the IO completion port purely for synchronization.
Cool.
It's an excellent tool. I really suggest reading up on it if you've got if you're really using a lot of critical section code. You get a lot of thread contention. Now, one thing that saved us from a ton of thread contention, again, is that we put our own database connection into each worker thread. So because of that, we didn't have to worry about making all of our code thread aware, because each one would effectively have its own copy of its own state. And that's something that really helped us out. So those are a couple things to remember. Now, for exception handling, we did not use exception handling. Primarily, that was because we were trying to keep the size of the app really small. The exception handling does bring in about 25K worth of code. It's the same code that gets brought in with sprintf. So it's primarily the reason there. Okay. Bulk row fetching. Now, this may seem like a fairly obvious thing, but we found that it's extremely good, especially when you're approaching your network bandwidth limit. The thing is it takes quite a bit of time to come up on the wire for a network hit, for an RPC call. And the more of these calls that you're making, obviously the slower it's going to be. So the obvious optimization there is to try to put as much into one of these RPC calls as you possibly can. And that's where bulk row fetching comes in. Now, ODBC does a really good job with this. Pretty much all you got to do is set the adder row array size, and you tell it, say, hey, I want 10 of everything. And it assumes that you've got enough memory to handle it. It just pretty much dumps 10 rows down into your buffer. Now, that in of itself is pretty straightforward. OLADB, again, you would do that by kind of fetching 10 row handles, then getting 10 row handles, and then getting the data for each row, hoping that the provider would fetch 10 rows immediately. However, where we found the big win here was with SQL Server. Now, SQL Server has some really good forward-only cursors. They call them fast-forward cursors. And effectively what they do is, say you want to select a row set of about 50 records, and you want to fetch the first record. When you fetch the first record, these fast-forward cursors kick in, and they actually transmit the other 49 records down along with it, figuring you're going to fetch them sooner or later. So what it does is it makes your transfer of that on that wire larger, so there's more immediate data. But once you've got it, if you're going to fetch that kind of data anyway, then you don't have to come up on the wire again and again and again. It's just transferred in one batch. This was exceptionally good for us in keeping that network bandwidth down as much as we could. We found it pretty much the last part of the week was spent just trying to tweak as much as we could to try to keep getting as much as we could from the network more than anything else. This question right here.
In that case, do you want to look at the size of the row, the row size that you're returning and match that to your...
An excellent question. The question is, do you want to look at the row size? Absolutely. I mean, if your row is like a couple megabytes, you're going to be sorry. In our case, the rows that we were transferring down were fairly small. They're usually textual data, somewhere in the neighborhood of, say, probably about 200 characters per row. So for us, saying 50 rows is only about 10K, give or take, or excuse me, 1K. I can't think right. So in our case, the size does, in that case, how much size you're passing through does matter quite a bit.
So then, depending on your application, you might actually really want to set that attribute size depending on the various...
Exactly, yeah. So a good way to think about it is if your row size is larger, maybe you want to tweak that array size down a bit. In our case, what we would do is we would kind of agree upon with the testing guys that were testing this what a reasonable value of records we could pull down. It turns out there are some searches in the database that would return like 260,000 records. Now, you go to anybody's website and they're not going to give you 260,000 records except for maybe Yahoo and Alta Vista, and then you're going to sit there for 3 days and you're going to give up, right? So, what we agreed upon was a reasonable set of data, usually about 50 records that we would bring down for a search. And in that case, we knew exactly how much we wanted to bring down. So we could already have all the buffers set up. We knew how much data was going to transfer. It also turned out it was useful in determining exactly how much efficiency we were getting out of our network in terms of our hubs and everything. Believe it or not, hardware actually does, with your hubs, plays a bit of a factor in this.
Take into account IP size or anything like that?
Yeah, in our case, didn't really mess with that in terms of IP size. Go over here.
Can we achieve similar kind of workflow semantics using that radio client-side process?
Yeah, can you use, the question is, can you kind of get the same type of stuff using ADO client-side cursors? Yes. You pretty much can get ADO. We'll go ahead and ask it to fetch the number of rows that you want. Also with OLADB, you can tell it how many rows you want it to go ahead and fetch. ADO is actually a little bit more aggressive at that than just straight OLADB, because if it says, oh, well, you wanted 50 rows, I'm going to go out and get the data for 50 rows right now. Whereas with OLADB, you'd say, well, I have the handles to 50 rows, and I'll get them as you ask for them. So the thing, though, to remember, the one thing to kind of remember, though, is most of the time, especially like the SQL Server provider on OLADB and ADO, I'll get to you in just a second there. When you say, give me the handles for 10 rows, that provider is going to go out and bring over those rows, and they'll actually be local to your process. So in effect, it's as if you already kind of fetched them anyway. So when you go out to ask for the data for those rows, you're not going all the way out to SQL Server, you're just going to your provider. Now that's not necessarily the case, though, with every provider, though, so I want to caution you about that. Question back there. Does the 2.5 or 2.6 SQL Server provider include this as an option? In terms of just bringing down all the records at one time? It doesn't really turn it as an option. It just kind of goes ahead and does it for you. Now, you can actually twiggle with that a little bit. There's a property that you can set on the provider called max open rows. And if you set that lower, it will try to force it down. If you're really curious about that, just come up and talk to me afterwards. It's one of these random OLADB properties. Okay, insertions. Now here again is kind of a religious subject. Just to kind of give you an idea, I look out on the Developmentor OLADB news groups every now and then, and there's currently this discussion as to which is a better way to insert, kind of bulk inserts or stored procedures. And it's kind of like the old Miller Lite commercial, tastes great, less filling, So what I'm going to kind of do here is kind of talk about both of them and in terms of the pluses and minuses. Now in our case, we use stored procedures to do all of our insertions. That's primarily because we were always inserting one record at a time because of the dynamic of our application. In other words, we were always grabbing one book at a time. We weren't really, we were changing one record at a time. We weren't changing 100 records. Now, we had actually thought about trying to do that, to build that into the code, but the problem we would have run into is when they pull that NetTap cord on the fault tolerance, anything that hadn't been transmitted yet would effectively be lost. So in our case, we had to kind of go for to some extent, the lower performance of calling it every time we did something, because we just absolutely did not want to lose any state, any data from the user. So we were quite conservative in how we did our approach. Now, one of the reasons I like SQL Server stored procedures is generally, again, they're already compiled for you. They're already sitting there. They're ready to be run. The thing I always kind of get nervous about is insert into statements, because it's very easy to fall back into that trap of putting different string names in there and having SQL Server having to validate it each time. I would say if you're going one of those routes, I'd maybe go for the stored procedure in that case, just as my personal opinion. Now, the other thing that you can do with SQL Server, and this is something just specific to SQL Server itself, is if you want a batch update, then you have two good options. You have either the iRoset fast load option in OLADB, or you also have the SQL bulk operations in ODBC. Now, effectively, what both of these things do is, on my client side, I'm going to insert a bunch of virtual rows, and then I'm going to commit them all at one time back to SQL Server. Now, I find this is probably most useful when you're initially populating a database or you're initially trying to get a bunch of data over into it. But I'm sure people will find many different uses for this. In my opinion, if you're not going to use a stored procedure and you really want to go for that batch insert, then these options are really good things to take a look at, primarily because their SQL servers optimize itself to take in this data. Let me show you a demo of this. I'm going to actually use OLADB for this one as opposed to ODBC, just to kind of show you, be kind of methodology independent here. What I'm going to do is I'm just going to cook up a quick little sample here, show you how to do the iRoSet fast load interface to insert a bunch of records very quickly. Let me switch over to my demo machine. And let me go ahead and just create a new app here. Warning, coding ahead. And I'm just going to create a little Win32 console app. I just really keep it really small, and I'm just going to call this, MyFast. And it's just going to be a very simple Hello World app. We'll just go ahead and create this. Now, the first thing I'm going to do here is I'm going to put in some header files, or some additional headers, to bring in what we call the OLADB consumer templates. How many of you have never heard of these before? A couple of you, a fair number of you? Okay. OLADB consumer templates are a new feature with Visual C++ 6.0. And if you want to think of them as kind of ATL's version of data access, that's kind of the best way to think about them. We use templates. They're very, very small, very, very fast. We can put them into your application for as little as 2 kilobytes of code size, to kind of give you an idea. So what I'm going to do here is I'm going to go ahead and bring in those. And one thing before I forget, in order to make this sample work, I'm bringing in a couple of class IDs, so I need to set a define there to engage them. And I'm going to go ahead and insert this. And let's see, I think I've got these here. There we go. I won't try to type everything here. Basically, all I'm doing is I'm including 3 files, ATL base, ATL com, and ATL DB CLI. Those are the 3 files to bring in the consumer templates. Now, my source files, what I'm going to do is I'm going to first go ahead and include SQL OLADB, if I can spell that right, SQL OLADB.h. That's the actual file that contains the definition for iRoSet fast load. It's available on the Platform SDK, and it's available in the DevTools install of SQL Server. I do not believe you will find this hanging around in Visual C++ or Visual Studio. I looked for it and I couldn't find it, so be aware there. Now, the first thing we're going to do is we're going to create a little C++ class to represent our table. Now, I have a table sitting out of my SQL Server here called MyTable, and it's the table we're going to dump data into. So a simple C++ class, and it will have 2 data members. And I have a short for an ID and then a character description. Pretty standard. Now, the other thing I'm going to do is have a couple of status values. Now, this is something that's kind of unique to OLADB. The way you sometimes get debugging information back is through these status values. And for those of you who are using OLADB, the only reason I'm putting this in here is to kind of remind you that sometimes if some things go wrong, take a look at the status values. The thing you got to watch out for, you have to use only certain values when you're inserting data. Otherwise, this iRoSet fast load interface will give you an error, which I actually found when I was first researching this. Now, the status values themselves are just a couple of D words. Now, the thing in the OLEDB consumer templates, we have yet another map, right? It's a requirement, by the way, that we must ship at least one new map in every version of Visual C++. So, you know, we of course have to come through with that. Now, in this case, what it is a column map. Now, what I want you to think of if you're an ODBC user is that for each one of these macros I'm entering, it's an equivalent call to SQL bind call. That's really what I'm doing. Now, I'm doing a column entry status here because I'm going to bind these status values as well. And I'll have my ordinal for the ID field. And then I'll have I'm going to have the second one here for the description. And there we go. Okay. Just a simple C++ class, and when we actually get to the point we're ready to insert data, that's what we're going to populate the data in before we insert it. So we'll be setting new data into those data members for NID and SC description. Now, within my main application here, now remember that OLEDB uses COM, and for any of you who've ever taken Don Box's course, what's the first thing you do? And what's the last thing you do? If you fail to do this, you'll wonder why you get errors. Now, once I've got the co-initialized, that's just to turn COM on and off. Now I'm ready to go ahead and start hooking up some of my code to connect up to the database. Now, in the consumer templates, we have two classes, a C data source and a C session. Think of them kind of as the equivalent of an HDBC and an H statement. They're kind of the equivalent of that. You kind of need both of them to do your operation. And really, you don't get to rock and roll until you have that H statement ready. Now, we have our standard H result. And now the next thing we're going to do is we're going to set some properties. Now, in OLEDB, everything works through properties. In ODBC, they'd be called attributes. And what we're going to do here is effectively, I think this is here. Yeah. We're going to effectively tell it to go ahead and first of all hook up to the pubs database on my local machine. And then, now this is very important, this is where the miracle occurs. We're going to tell it to turn on its fast load option. It turns out that if you don't specifically tell SQL Server to do this, it will just give up and not bother. It won't let you try to, you'll get errors when you try to use the IROSET fast load interface. In fact, it won't even let you query interface for it. Effectively, what all these properties do is they're going to go into an open call on our data source object. And I'm telling it the class ID SQL OLEDB, that's the name of the native SQL Server OLEDB provider. You need to use the native provider or this won't work. If you use the ODBC provider, forget it. Now, the next thing I'm going to do is I'm going to pass in all these properties. And because we're good COM programmers, we always check our H result. So I'll check it against SOK. And if that succeeds, then we'll open up the session. Now, one thing here, you might notice that when I opened up this session, I typed in the source. The name of the instance of the data source is the first parameter. Now, effectively, when you're dealing with OLEDB, you're dealing with a bunch of disjoint COM objects. You have a data source object, a session object, a command object, and a row set object. Those are the primary ones. Now, you might wonder about the case, what happens if I have this orphaned row set object? You know, it doesn't have a parent, doesn't have a data source, doesn't know who it's connected to. What happens? Well, the answer is not much. So the way you tell who your parent is the parent effectively passes itself in, kind of like the same process, you know, having a child, you give it your DNA, into the session object. And if anybody noticed, I just sneaked in the magic words secretly. Okay, so now at this point, now we're ready to deal with the data. Now to do this, what I've done is I've got a little class that I've kind of put together, cobbled together, to handle all the IROSET fast load. Now, specifically what I've done is I've made it so we'll hook in with all of the consumer templates. Don't be surprised, by the way, if you see this show up in the next version of the consumer templates, by the way. But there's certain advantages, to doing that. Let me just insert that, and let's see what I want here. This is a big hunk of, looks like a big long hunk of code, but all it is, it's a C++ class that derives from one of the classes in the consumer templates called CRowSet. In effect, this class is going to act like a regular row set. So you'll be able to move next, move previous, so on and so forth. The difference that we're doing here is that instead of using a standard COM interface for OLEDB, which is iRowSet, we're going to make it go through iRowSet fast load. I keep getting this backwards. Yeah, iRowSet fast load. So effectively what we're doing is we're just telling it to use a different interface rather than iRowSet. That's what all this code's effectively doing. Now the two important things here, there's a method called insertFastRow, and this is where we actually call the method on that interface called insertRow. That's where we're actually going to insert some data into our client side buffer, okay, or the client side cache, if you will. When we do this, effectively the provider will squirrel it away in its cache and then wait for us to call the second method called commit. And at this point, it will actually transfer all of the data out to SQL Server. Now it has, you'll notice on this commit call, if you can see it has this be done in there, it takes a Boolean value as its parameter. If it's set to true, you're telling SQL Server that you're done with the row set, you're done transferring data, and it should just go ahead and perform all of its integrity checks that it wants to, and it's all there. If it's set to false, you're basically saying, I've got 10,000 rows of data, here's the first 100, and I'm going to come back and give you another 100 at some point. That's basically what the difference is there.
Is there a good optimization for figuring out about how many rows you want to give it at a time, or does it matter?
Yeah, in terms of how many rows would you want to give at a time, it's purely dependent upon your particular situation. If you're doing a thing like where you're really worried about losing data, then you would want to set that number really low, right? Whereas if you're worried about just overall performance, because you remember every time you send us off to the database, it's going to be fairly slow, then you might want to keep that as a larger number. It really depends upon your individual situation.
But if I had 1 million rows or something, what's the big deal? Not so much for me.
Yeah, I mean, if you had 1 million rows and you didn't care if you just start over again, if some row didn't get inserted right, then you'd just let it party. Of course, then you'd watch your memory, your working set go go up like crazy. Now, all this class does is it's going to allow us to use that iRowSet fast load interface. Now, what I'm going to do is I'm going to hook this in, and we're going to make effectively a class that's going to use, first of all, remember that C++ class we created before called CMyTable? And then the row set that we just created, okay? And I'm just going to call an instance of this myTable. Let me just make sure that I've named this right. C row set fast load. I always call this C fast load row set for some reason. And all this is, it's a big template instantiation of just a local data set that's going to allow us to dump data into instances of myTable and then insert them and commit them with that iRowSet fast load. That's all that big thing means. Now, we go ahead and hook this up by calling open. And again, remember that parent-child thing? We do that again with the session. And here, we tell it the name of the table that we're going against in SQL Server. In this case, it's called myTable. Now, one big note, it's not select star from myTable, because if you look at your database, bring up the Enterprise Manager, there is no such thing as select star from myTable. It's just myTable. That's one kind of caveat with OLEDB. It wants you to sometimes be very precise. Now, if this works, then we're going to insert some data. So all I'm going to do here is I'm just going to do a for loop. And just for 100 rows. And what we're going to do is we're going to fill in those data members. So we're first going to have the NID field. We're going to set that to the I counter here. And then I'm going to do one of those evil sprintfs. Again, for demo purposes only. And we're going to put in just a text element, like call it data element %I. So all we're going to do is a textual representation of this. Now the other thing, remember I put those two status values in? If you forget to do this, you're going to get an error. Now there's a couple things you can do. You can first of all just not bind them, but that sometimes is a little bit harder if something goes wrong. Effectively, if something went wrong with the insertion process, these status values would be populated with a reason that it failed, which would make it very quick, much more quick to debug than if you're just sitting there going, what happened? Believe it or not, the name of the favorite error in OLADB is called DBE errors occurred. All right, so now what do? Well, use these status values to help you along. Now the trick is when you're inserting, the provider actually takes a look at these status values. So we want to tell it that the values that we have in there are valid and we're ready to go. Now we could set these to a couple other things. If we had null data, there's a value for that. And if we want it to default to whatever the server says is fine, we can do that as well. In our case, we're just going to set this. And what we'll do is we're going to call insert fast row, and that will actually insert that into the provider's cache. Note, it will not be on the server yet. Only when we get down to this step that I'm typing in now, where we commit that, do we actually put it on the database. And we'll show you that under the debugger here in a second. So one other thing that I'm going to do here is I do this in every demo I do with a console app because it's an easy way to avoid an error. You notice that Cohen initialized down there? Well, any of you who have read Don Box's book on C++ and Meyer's book on effective C++, and then looked at Don Box's version of what he thinks C++ should be, he hates smart pointers. For the reason is that they tend to just do various random things at various random times. And here's one of them. We use smart pointers internally within the consumer template so you don't have to worry about releasing or add-refing all these interfaces running around. But the problem is they only release when they go out of scope. Now, if you look, co-initialize is going to get called before it goes out of scope. So effectively, COM is turned off. Guess what happens if you try to release a pointer when COM's turned off? Access violation, right? So what I'm doing here is just forcing this to close. Exactly. And I do this the hard way just to show that you can do close. In fact, I have a bunch of code I use at home. I just normally do put in the extra curly blade, extra block effectively to force a close. Okay, so there's some code there. Let's see what we get. Okay, I admit I practice. Okay, all right. Oops, actually I want to go and, oh good, okay. I want to set a breakpoint here on my source. And we're basically just going to run to this. And at this point, I believe I have the query analyzers open. And I just want to show you at this point, we have a really bad thing here where the network is broken. That's nice. We'll see if it's happier now. Yeah, there it is. Okay. So there's no rows in this thing right now. Okay. What we're going to do, let's go through this. We're going to go through our code here. By the way, how many of you are not using Visual C++ 6.0? Okay, so I always love to show people this, that my favorite thing is just the comma HR. You know, now the problem is I lose one of my best trivia questions. What's 80004005? Yeah, someone got an e-fail. Yeah. I used to give out a t-shirt for that. Anybody get that right? So I'm going to step through this. And effectively all we're doing here, let me scroll this up to the top so we can get some more visibility here. We've opened our session up, and now we're going to go in and open this table up. So at this point, hopefully everything works. We're actually hooked up to that table on SQL Server. We've got all of its metadata. We know what we're going up against. And now we're going to actually go in and start inserting data. So we start with 1, and we create a data element 1, and we go in and insert this into that fast row. Now I've stepped over that line, and if I go back over to my query analyzer, there's still nothing in there because it hasn't been committed yet. So if I come down here, just let that run down to the point where I get out of the loop, again, nothing in there. Now if I go across and just commit this guy, then it actually goes out to the server. Now, my server's local here, so that would probably go a little bit faster than would normally be the case. And at this point, now we have rows. So that's a useful technique for keeping that all kind of contained on your client space before you're going to send that off to the server. There's several different things that you can do with it regarding integrity constraints, things like that, but this is pretty much the base standard usage. In effect, load it up on the client side, then send it over all at one time. So, you have a couple options there with insertions. You can either do an insertion on your stored procedure. You can do it. You can do it on an insert to SQL statement, but that one might be a little scary. Or you can use some of the bulk operations, which are really, those are just some of my favorite things that SQL Server always does. They always think about the fact that you're going to have to move data around, which is really nice. Now, I'm going to finish up here pretty quick because I think there's a comedian on tonight, right? Is that? Oh, there's always something going on. Let me talk a little bit about database indexes. If you don't use indexes, you should, right? I mean, or you should think about it. Because indexes, most of the time, at least for large data sets, can be very, very helpful. Basically, think of an index as kind of an in-memory lookup table. And what you do whenever you want to search for something, and you're sorting and you're trying to search, rather than having to have SQL Server go through and figure this out dynamically, it can go through and just look this up in the table and give you the results that you want. Now, the nice thing is that you can create these with a wizard. As of SQL 7, you can also do that with SQL 2000. It makes it very easy, very quick to handle. Now, the downside to indexes can be that it takes longer to do an insert or an update because it has to go through and redo this table. Now, the general thing there, don't just not use an index because you have to do an insert, but just take a look at how many inserts you're going to be doing, what's the size of this table, how much you're going to be using it. If you've got a fairly small data set, it's not going to take you very long. Maybe an index isn't very good. In our case, we'd have indexes on 3 million record rows, or 3 million record tables. So we would, for us, it was an incredible speed up. To give you an idea, we had one query without an index that ran like 10, 15 seconds, and afterwards it ran at 150 milliseconds, right? So just put the index in. Now, if you're interested, a formula for indexes here, and generally I always, some of the guys have told me that the best way is order by columns and search by columns and then fetch columns. In effect, you want the sorting kind of done out of the way, for you. You really don't want to be trying to sort. So in the case here where I'm like selecting job description, minimum level from jobs, where job ID, this actually should be ordered by job ID then max level. You would want the index to be max level, job ID, job description, minimum level. The reason is you have your order by there, which is maximum level, which comes first. Then you'd have your job ID, which is your search criteria. and then you would have your job description and minimum level, which are your fetch columns. In effect, think about what's going to happen. The ordering is already done, so what you're going to be doing is you're going to be going down this table. It's already sorted for you. You're going to do your search, and then you're going to fetch your data. In effect, you're always kind of going in this direction. Without that, you'd be kind of bouncing all over the place. Okay, I've got this data. Now I need to sort it. Now I need to find out the right result set and hand it back. In effect, that's already done for you.
Does it buy you anything to have the selection criteria as part of the index?
Yeah, in this case, I'll admit I made a little bit of an error here that I realized when I was up here. You generally would want to order by the lead column in with the maximum level. In other words, that you want the job description to be in there as well. You basically want the predicate to take advantage of that. So I made a small boo-boo there. Now, one nice thing, if you don't get the index right, guess what? SQL Server will tell you about it. This is my favorite feature in SQL Server. It gives you the ability to look at your indexes, and it will tell you whether you need them or not. The way you do this is you turn on the index tuning wizard, and you input a trace using the SQL Server profiler. All you do with this guy, you start it up, you let it run on your server, and then you just use the database like normal. After a while, you turn it off, you save your trace out to a file, you run it through the tuning wizard, and it will tell you what it thinks you should do with your indexes. It'll tell you if you should add indexes or remove indexes. And when it's done, it gives you an estimation as to how much it thinks it will improve your performance. This is incredibly nice because it actually gives you feedback. You're not sitting there trying to, maybe this will work or maybe this will work. You're actually getting feedback from the server saying this worked, this didn't. Now, query analysis. I want to be very careful here before I say too much about this. Everything I have on this slide pertains to the fact that you're doing high throughput, high volume data. If you're doing a very small data record, some of this stuff may actually work against you. Now, in case where you have a lot of data running around, SQL Server Query Analyzer can actually help you out quite a bit in that it can tell you what it thinks a stored procedure is going to do before you do it. And there are some things to watch for. First of all, never look up on a table. Always look up on an index if you've got a lot of rows, because you want this already sorted for you. You already want that data done for you. You also want to be careful, how many rows are you actually returning? Do you need to return all those rows? I've heard people say 10, 100, 1,000. I just say 100 rows is a good average number. You'll tweak that up and down on your circumstances, but only return what you need to do. If you're returning 10 million records, probably your server can do a little bit more work for you. Probably save you a little bit of time in the end analysis. In some case, a simpler query, though, returning slightly more data can actually be a little bit better. We had a case where we actually fetched 50 records, even though we were only going to immediately show 10 of them. But the query was simpler in that it was able to use indexes more effectively and use less CPU hits. So in that case, it actually worked out a little bit better for us. Now, again, I'm talking about 50 records here. I'm not talking about 50,000. Last but not least, surprisingly, this is one that's easy to miss. Take a look at what your data is doing. Look for trends in your data. This isn't necessarily the easiest of things, but sometimes it can yield great benefits. To give you an idea, when we did this benchmark, we had one table that was 1.2 million records. The problem was only about 600 of them had this thing called a valid subject query. This particular table was searched by subject. And we found out that only 600 of them at any time would ever be valid. The rest of them were just there. The database was given to us, and we asked about it, and they, I don't know. So we said, okay, well, fine, we'll code our stored procedure to only use valid records. So instead of 1.2 million records, which took about 40 to 60 seconds, we did 600 records, which took a lot less, right? Which do you think is going to be faster? You're not always going to be able to get a good indicator from this, but it can be useful. Last thing, but definitely very important. Some of the new things you can look forward to in 2000. XML. The ability to give data back already formatted, ready to go. Just dump it into your output stream. You don't have to mess with it. just let the server put it into XML format for you and send it on its merry way. Because remember, your client side, your browser, whatever, is still going to have to go through and parse all that out anyway. The ability for your server not to have to mess with all the HTML tagging and setting all that up can really help you out. Index views. This one is extremely good if you've got any joins or views sitting around. Before you wouldn't be able to put an index on these, and now you can. And in our case, like we had one situation where we were doing a join where we thought significant about using a view just to represent that in memory, and we didn't do it because we didn't have this feature. So I think if I did this work now, I would take advantage of that new index. And last but not least, those nice little computed column indexes. All those auto-increment fields can be very, very useful. This question right here.
Yeah, talking about the index views, and I take it you use the sort procedure to do the join, and you're saying you would choose the index view over the stored proc.
Yeah, in our case, I'd probably use the view over the stored proc, or I would change the stored proc to take advantage of the view. Let's put it that way. In the sense the stored proc wouldn't have been as expensive to run from that, its overall performance. Okay, thanks for sticking with me for an extra 5 minutes or 5-10 minutes here. Little things mean a lot, guys. I mean, that changing some small stuff in your code can really improve it. The great thing, again, C++, SQL Server can always go one more level, right? You can always play with one more thing. I've actually only covered some of the optimizations that we did. I've actually, on the next slide, I'll point you out to the web for an article that we wrote on some of the other optimizations we did, like with the ISAPI DLL and the worker thread pool and things like that. But there's just tons of stuff that you can always do with that combination. And obviously, you got even more stuff to look forward to with SQL Server 2000, from the sense that you now have more ability to take more control over that data. And that's, really when you're doing the highest performing applications, you really want to know what's running when and where and how. When you know that, you can optimize it effectively, and you can get those great numbers that you see up on those charts. So come next Christmas, while your competitors' sites are crashing and going boo-boo, yours is up there running strong, and you're raking in the dough, right? So, go to it, guys. I've got an article here for you to look at. It's real easy to find. Just take a look out on the Visual C website. We'll point you out to a white paper, and it just says, look for PC Week article. It actually gives about 30 different things that we did to put that app together, including like all the ISAPI stuff, everything, that, a lot of other things I didn't cover here. So with that, thank you very much for coming. I hope you enjoyed the talk, and any questions, just come on up.